Hi, my name's Julie Roman, and I'm from the tech marketing team for the Cloud Management Business Unit at VMware. Today, I'm going to go over vRealize Log Insight architecture. The vRealize Log Insight deployment is fully documented as part of the VMware validated design. In a multi-region implementation, Log Insight provides a separate logging infrastructure in each region of the SDDC, which requires a cluster per region. You can configure event forwarding to Log Insight clusters in other regions. This means using vSphere replication or disaster recovery by using Site Recovery Manager is not required. The event forwarding feature adds tags to log messages that identify the source region. Event filtering prevents looping messages between the regions. Using the VMware validated design, all the nodes have routed access to the vSphere management network through the Tier 0 gateway for the management cluster for the home region. Routing to the vSphere management network and the external network is dynamic and is based on the Border Gateway Protocol. As part of solution interoperability, VMware NSX users on Standard, Advanced, or Enterprise editions can license vRealize Log Insight with their NSX license key. You can configure systems to send log messages via syslog to the virtual IP of the Log Insight cluster or a standalone instance. As of Log Insight 8.2, you can securely send log messages using syslog over TCP. vSphere and vRealize operations configuration can be configured from the Log Insight server using the UI. Log Insight agents can be installed on Linux and Windows operating systems and configured to send OS and application logs. The agent collects events from log files and forwards them to vRealize Log Insight or any third-party syslog destination. You can use log forwarders for a number of use cases, such as filtering logs before sending to a security information and event system, so they only include security and audit logs to meet compliance requirements. You can aggregate logs from a protected network, forward logs across sites for HA or disaster recovery. You can add metadata to log events without modifying the original logs, so tagging from a source data center or application. You can also archive logs for long-term retention. A few things to note about methods for sending log data. The options are using the ingestion API, syslog, or sending in raw format. For the ingestion API, the source is the initial sender's IP address. For syslog and raw, the source is the event forwarder's Log Insight IP address. The message text contains li_source_path, which points to the initial sender's IP address. Events and messages transition through the following stages. A device generates a log file. It's picked up and sent to Log Insight in one of the following ways: via Log Insight agent using the ingestion API or syslog, through a third-party agent such as rsyslog, syslog-ng, or log4j using syslog, or by custom writing to the ingestion API or syslog, such as a log4j appender. Log Insight receives the event. If you are using the integrated load balancer, the event is directed to a single node that is responsible for processing the event. If the event is accepted, the client is notified. The event is passed through the Log Insight ingestion pipeline, from which the following steps occur. A keyword index is created or updated. The index is stored in a proprietary format on a local disk. Machine learning is applied to the cluster events. The event is stored in a compressed proprietary format on the local disk in a bucket. The event is queried. Keyword and glob queries are matched against the keyword index. Regex is matched against compressed events. The event is moved to a bucket and can either be deleted or archived when disk usage is at 97% of capacity. A bucket is sealed when it reaches 500 megabytes. Buckets are deleted in first in, first out order when disk utilization is at 97% and the oldest events will be overwritten. Data stored by Log Insight is immutable. After a log has been imported, it cannot be removed until it is automatically retired. This is an example of the notification administrators will receive prior to Log Insight overwriting files. Log Insight was built using a leader-based architecture. This allows for query and ingestion high availability. The user interface can be served from all the nodes, and there's no single point of failure for ingestion or the user interface. How does it work? The integrated load balancer directs traffic to the leader. The leader then sends subqueries to the workers, and the workers send the results to the leader. The leader aggregates results and displays this back in the UI. Log Insight has the native ingestion API engine. This is responsible for ingesting logging data over the ingestion API by using one of the following methods: using a Log Insight agent that has been deployed, or pre-configured on SDDC components such as Site Recovery Manager or VMware Cloud Foundation appliances. There's the integrated load balancer. This is responsible for load balancing incoming UI and API traffic and its incoming data ingestion traffic. The integrated load balancer is a Linux virtual server that is using layer 4 load balancing. Each node of Log Insight contains a service running the integrated load balancer, but only a single node functions as a leader at all times. In a scaled out Log Insight cluster, this role can be inherited by any of the available nodes during the election process. The leader periodically performs health checks to determine whether a re-election process is required for the cluster. There is also the configuration database. This is a Cassandra database that stores information about the Log Insight nodes and the cluster. The information that is stored in the database is periodically replicated to all available Log Insight nodes. The log repository stores logging data that is ingested to Log Insight. The logging repository is local to each node and not replicated. If a node is offline or removed, the logging data which is stored on that node becomes inaccessible. In environments where an ILB is configured, incoming logging data is evenly distributed across all available nodes. When a query arrives from the ILB, the Log Insight node holding the ILB leader role delegates the query to any of the available nodes in the cluster. There are 5 sizes for Log Insight nodes based on the number of connections and the ingestion rate in your environment. Extra small nodes are reserved for proof of concept deployments. You can upgrade an environment to extra large nodes if there is heavy query load. This can be observed if there is slow query response time and continued query load of several dozen requests viewed in System Monitor under active queries. It is actually possible to increase nodes up to 256 gigabytes of RAM per node. The best practice is to keep one node per ESX host when possible. The nodes are ideally deployed in a management cluster, and affinity rules are set to keep nodes on separate hosts. The max storage is 4 terabytes per node, and the max disk size is 2 terabytes per disk. If you want to configure the maximum storage per node, you can use 2 2-terabyte disks for maximum performance. When you reach the maximum disk space per node, you'll need to scale outward with larger cluster size instead of adding more disks to existing VMs. A Log Insight cluster deployment can scale out to 72 terabytes. There are other integration maximums. You can only pair Log Insight with one vRealize Operations Manager instance. You can support 15 vCenters per Log Insight node. We currently support 1 Active Directory domain, 1 email server, 2 DNS servers, and 4 NTP servers. You can have a maximum of 10 forwarders configured per cluster. You can increase the RAM and CPU and storage after deployment. You need to power down one node at a time and add resources. You can also remove or add nodes. The optimal storage configuration and search configuration is to scale up rather than out. There are a couple of cluster prerequisites. The minimum cluster size is 3 nodes. The recommended is 4, and this helps with the Cassandra database failover. It fails over a little bit more quickly. All nodes must be in the same data center and on the same layer 2 network. They must be exactly the same size. Now, during an upgrade process, they can be dissimilar for a short period of time while you're adding resources to the nodes. All primary and worker nodes must have the same SSL certificate, and time must be synchronized on all the servers. So a few things to remember about deploying vRealize Log Insight. You want to make sure you deploy the appropriately sized appliance. Notice extra large is not listed on here because that's something that you might add on later if you need it for the query performance. You want to provision eager 0 disks whenever possible, specify no more than 2 DNS servers, and use affinity rules to keep Log Insight nodes on different hosts. You can deploy additional nodes to support the environment. You simply deploy a new node, and when you connect to it, it'll ask you if you want a new deployment or to join an existing deployment. Log Insight uses an integrated load balancer, and this ensures that incoming ingestion traffic is accepted even when some nodes are unavailable. You can configure multiple virtual IP addresses if you want to use this for tagging specific log messages. External load balancers are not supported for using Log Insight. The best practice is to include an integrated load balancer in all deployments, including single node instances. Integration with vCenter. You simply add the vCenter server credentials with the required permissions over on the right-hand side. Once you add the vCenter, it'll ask you if you also want to add the hosts, and you can select yes, and then you will have logging configured for your vCenter and all the hosts in that vCenter. You can also unselect specific hosts if you don't want to receive those log messages. For integration with vRealize Operations Manager, you do need full admin access if you want to use the launch in context functionality. And why would you want to integrate with vRealize Operations? Well, it has features that help calculate and send metrics to vRealize Operations. So this enables vRealize Operations users to have insight into logs without going into Log Insight. The dynamic threshold calculation will make this feature even more powerful. If there is a high rate of some error logs on some hosts, this is an indicator that the host needs attention. A threshold marks the boundary between normal and abnormal behavior for a metric. vRealize Operations Manager supports dynamic thresholds that are calculated from historical and incoming data. You can recalculate dynamic thresholds at any time to capture the most recent data. I hope you've enjoyed this session today. For more information, please check out our website.